All right, before we looked at converting between polar and rectangular coordinates, now we're going to look at seeing what polar graphs look like and then how we can convert those to polar equations and rectangular equations and their graphs. So before we get into any examples, these are some important formulas that we're going to be using. We will use these formulas, the formula of a circle. We have this, x squared plus y squared equals r squared. That's a formula for a circle, or the equation for a circle, standard equation for a circle. The x equals r cosine theta, y equals r sine theta, and tangent equals y divided by x. We're going to use these to convert between polar and rectangular equations. There we go. So let's take a look at that. On this example 1, it says graph the polar equation r equals 3. Now that's a little bit weird. I don't know what to do for that. Actually, I do. Here we have a couple things involving r. We have x equals r cosine theta, y equals r sine theta. And we also have this formula. If I square both sides, I should still have something that's the same. The equal sign will be okay, and you'll see why I'm squaring both sides in a minute. So if I do that, I'll get r squared equals 9. However, my r squared is equal to x squared plus y squared. So instead of writing r squared, I'm going to write x squared plus y squared, and then keep that 9 there. Now I know what this looks like. This is a circle with a radius of 3. Sweet. And it's centered at the origin. So there I have the middle. I'll draw a circle. And this distance, 1, 2, 3. That's 3. 1, 2, 3. Yeah, circle with a radius 3. That's it. That's how you do it. Usually we're going to be using our important formulas here to get something with just x's and y's and no r's, no thetas. So we're trying to get an equation without r's and without thetas, without the radius in there and without the theta in there. So let's look at another example. What is that? Isa nothing. Example 2. Here we have theta equals pi over 4. Same idea as last time. So what do? Well, I'm going to look at my important formulas. If I were to use, because here I have a theta, so I might be able to use that. If I were to use this, though, I might still have an r value, or like an r variable in there, so that won't actually help me. But tangent, that doesn't have an r, this equation doesn't use r at all, so what I can do is use that. Tangent of theta equals equals y over x. So then I have tangent of pi over 4 equals y over x. My r's and my thetas are gone. Tangent of pi over 4 is 1. So 1 equals y divided by x. Multiply x to both sides, and I get y equals 1x, or just x. And that's just a line with y-intercept of 0. Yeah? So that's simple. If we want to graph that, it just looks like that line. 1, y equals x. Easy. What about this one? How can we do this one? Well, I already know, if you look back at your important formulas, this is y. So to make this without an r and a theta, you just substitute y equals 2. That's a line where y is it's just 2. It's that line right there. This is the x-axis. This is the y-axis. That's it on that one. We're trying to graph these. What about this one? Huh? You can maybe guess what to do. This part is x. So we just have x equals -3. That's a vertical line. 1, 2, 3 at -3. Just through there. That's so easy. It's like a peasy. We're just flying through these examples. Flying like a beagle. Oh, now this one's a little bit trickier. Okay. On this one, the trick when you have r equals something involving sine or cosine, this is the idea. This is the trick. You multiply both sides by r. Then what happens? Well, you get r squared, right? And then r times 4 sine theta, right? And then you get r squared equals 4r sine theta. And then this part, r sine theta, that's y. And this is x squared plus y squared. So we have this for y, yeah? And then we're just completing the square. This is actually going to be an equation for a circle. This is going to be an equation for a circle. And we're just going to complete the square real quick. I'll just get all the variables to one side. So then I'll have x squared plus y squared minus the 4y. And that's going to be equal to 0. Yeah, just getting it over to one side. Then I'm going to complete the square. And I'm going to do that for the y's. No, the y's one. So that'll be y. Remember, the way I do it is I cut this one in half. So this will be minus 2. Then quantity squared. And always subtraction on the outside. And then I take this and I square it. That's how I get this part. And so negative 2 squared is 4. And then that's going to equal 0. So then I copy down that part. So there we go, like that. So now I have x squared plus y minus 2 squared equals 4 if I get the 4 over to the other side. Now this is a circle. This is a circle. And remember, you move, this would say you move down on the y-axis for the circle. It has a radius of 2 because this is radius squared. I don't know if I said move down on the y-axis. I meant move up on the y-axis. Remember, you have to do the opposite of what's showing. Yeah. So to graph this, I'll just do it like this. It's up to 1, 2, and then it has a radius of 2. So it looks like that. It's a circle moved up on the y-axis. I think that's all we're gonna look at for today. For now. For this. So that's interesting. Oh, look at these notes. Oh, look at all these notes. I just wrote them down. This is how it is. These notes. Goodbye.